natural state or natural length, and the block is released. Block of mass m is released. They'll ask what is the maximum velocity acquired by the block. Okay. Find the maximum velocity acquired by the block. Okay. So you have to understand like this. The moment you release, basically mg force is acting. Only mg force is acting because spring is in the relaxed state. So because of mg it will have an acceleration. But as it comes down, the spring will stretch and restoring force will start acting. So as long as there is a net acceleration downward, the velocity will go on increasing. As long as there is an acceleration in the net, and net acceleration downward means there should be a net force downward. So actually what is happening in the free body diagram, if you draw the free body diagram, you will find that mg is a constant force. Mg is a constant force, but this restoring force is increasing because x goes on increasing. X goes on increasing. So as long as x is less, as long as kx is less than this, there will be net force in this direction. And as long as there is a net force in this direction, it will go on accelerating. So a stage will come when it will be just equal to this. A stage will come when this will be just equal to this. Net force is 0, means acceleration has become 0. So now the velocity will be maximum. Thereafter what will happen? Because of the momentum gain, it will go further down. So kx will now be more than mg. So there will be retarding force. So the block will slow down and finally comes to rest. So at the instant of maximum velocity, acceleration is 0. Because as long as there is an acceleration, velocity will go on increasing. The moment acceleration becomes 0, velocity is maximum. Because thereafter, acceleration gets converted into retardation and the block will slow down. So at the instant of maximum velocity, acceleration has just become 0 because it will be converted into retardation. So that means net force is 0. Let us say extension is x naught at that instant. So then extension is how much? mg by k. At this extension, it has maximum velocity. So now you apply the